So, lot of talk going on deep seek. Really? Okay, okay. So, really, it has jolted the entire AI industry. Sir, you are having the copy of the book, no, Professor?
Yeah.
Yeah. So you after after you discuss, you will be showing that this one. Yeah. The fine, sir. That's good.
When will I have to show the book?
Huh? Yeah. So what after the introduction and then I will be asking you to formally address the sort of formally release the book and then address the participants. At that time, you can just say after few introductory remarks, you can show the book, that you are happy to launch the book. And then you can talk about Tanmoy. Then you can address on the current scenario. So then we can take.
So also, I think you all will be taking some screenshots and things like that.
Yeah,
Right?
that's right. I'll be taking a screenshot.
Yeah.
Yeah.
Please share that with us.
Yeah. Definitely. We will be doing it, sir, because we'll be publishing on the various platforms, So we will be doing it. So both of you should be, your camera should be on. That's only thing. For Tanmay also, no? So
Tanmoy's camera is on.
Yeah, he's no, that's right. Now and then, we keep switching it off, no? So are we the budget allocation for AI mission, is it okay?
Yeah. Manpower, people.
Huh?
Money is not the problem in our country. The
Uh,
problem is competent people.
No, when people
Hands-on.
when people are spending hundreds of million, so we are only given some 1,000 crores for this year and something like that.
That is not the issue. The issue is, can you get really good people who will implement things and
Okay.
make it work at scale? So that is the challenge. India has been successful.
And also the restrictions on the latest chips and things like that, NVIDIA chips, does it have a impact?
There will be workarounds for that. That is not the problem.
Okay.
See, if India can implement things at scale like Aadhaar and things like that, this is a little different ball game. But they need to get the best people to implement it. If you get only talkers and not doers, you will get into.
No, but see, Aadhaar had its own sort of, it was more like an application. So that way, it was developing an application. But this seems to be a little different,
Every time there is going to be different, but the scale at which we want to do things, and we have an opportunity. The question is about talent, nothing else. It's not money, it's talent.
Yeah. Of course, there is a talent crunch is there. That is one of the issue that when compared to other countries, the number of researchers.
It's not other countries, it's a worldwide talent crunch on this subject.
Yeah, that is true. No, but the India, relatively, the less number of people are involved in this research. That is also to be taken.
Critical mass will take a little more time.
Yeah.
It will happen. Critical mass is there in the US. The overflow of that critical mass has now come to China. That is why you're seeing from China. Now there will be some overflow of that critical mass which will go to India and East Europe.
Okay.
And that is when other alternatives will come. Give some more time, it will come. Making such tools is like making an aeroplane or making a ship. These are all engineering marvels. It is so. Um, AI is an engineering marvel. So other than it's like a ship, like everybody knows how a ship moves, but how to make a ship? Everybody knows how an airplane flies. But can you make an airplane? Have we made one passenger airplane? Same.
Yeah.
So it's the depth of engineering. We have made rockets now. We have made satellites. So we have certain kinds of expertise. This is a different kind of an expertise.
Akila, can we make a beginning? We can go ahead.
Yes, sir. My sir. Uh, Recording started. Okay, right. Uh, Greetings and good evening. On behalf of the organizing units, IEEE CS Madras, CSI Chennai, and ACM Chennai, it's my pleasure to welcome the speakers, the chairpersons, and office bearers of the organizing units, delegates, and the participants present in Google Meet and YouTube live streaming as well for today's presentation and the release of the book on large language models from pedagogy to research frontiers. I now invite Mr. H.R. Mohan, Chair Events, IEEE CS Madras, to deliver the welcome address and introduce the speakers to the participants. Sir, please, sir.
Greetings and good evening to one and all. So let me once again, on behalf of the organizing units, extend a warm welcome to our chief guest, Dr. Partha Pratim Chakrabarti, and the speaker and author of the book, which is getting released, Dr. Tanmoy Chakrabarti, the members and my colleagues from the organizing units, participants who have joined the event through Google Meet, and those who are watching the session through the YouTube streaming. Warm welcome to everyone. We have been doing the book launch program on a regular basis for quite some years. So far, we have done over 15 book launches, followed by a presentation by the author. Our another popular event is the author presentations, where the authors of popular books on topics of current interest and high relevance deliver technical presentations. We have done more than 20 such events. Today's event is on a trendy topic, large language models. Overnight, AI became a household name in November 2022 when ChatGPT was released. The global AI community had a big jolt when the DeepSeek language model was released few days back. The topic of LLM is being discussed in all forums, and debates on whether India should build such foundation models or focus on small language models, and also how to strengthen and upskill our human resources in most happening tech area of artificial intelligence. In this context, today's event is highly relevant since it is related to the presentation of large language models from pedagogy to research frontiers. After the formal release of the book by chief guest, we are fortunate to have Dr. Partha Pratim Chakrabarti, popularly called as PPC, Professor of Computer Science and Engineering and former Director of IIT Kharagpur, as the chief guest. The book Introduction to Large Language Models being released today is a comprehensive book and provides an in-depth exploration of large language models, covering the fundamentals of natural language processing, neural networks, the modern AI techniques. It delves into key areas such as word embeddings, transformers, and the intricacies of pre-training and fine-tuning, offering insights into evolving landscape of large language models. This book also addresses advanced topics like bias mitigation, hallucination, and responsible AI, highlighting their significance in ensuring ethical AI behavior. With an emphasis on practical applications and future trends, it is expected to serve as a valuable resource for the researchers, students, and professionals in the AI field. The presentation, which is going to follow after the release of the book, is aimed to provide the audience the insights into pedagogical aspects of the book launch, the current trajectory of LLM research, and practical implications of building responsible and inclusive AI systems. The presentation will begin by exploring the motivation for writing a textbook on large language models, emphasizing the growing significance of LLMs in academia, industry, and research. The author, Dr. Tanmoy Chakrabarti, will discuss how the book serves as a bridge for senior undergraduate, master students, and early researchers, providing fundamental concepts and advanced techniques to navigate the rapidly evolving landscape of large language models. He will provide an overview of the book structure, highlighting the key chapters and objectives from the theoretical underpinnings to practical applications. Following this, the presentation will transition to recent trends in LLM, specifically delving into the recent work in building economical, adaptable, and interpretable language model for social good. Now, I have the pleasant task of formally introducing your chief guest and the author come presenter. Dr. Partha Pratim Chakrabarti, popularly called PPC, after his BTech and PhD from the Department of Computer Science and Engineering, joined the same department as a faculty member in 1988 at IIT Kharagpur. And he is currently a senior professor with joint appointment in the Center of Excellence in Artificial Intelligence. From July 2013, he was the director of IIT Kharagpur till July 1st, 2019. He was the professor in charge of the state-of-art VLSI Design Laboratory, which he helped set up, and has been the dean of sponsored research and industrial consultancy at IIT Kharagpur. He set up the incubation program at IIT Kharagpur and was the head of Advanced Technology Development Center. He was also the co-director of the Strategic General Motors IIT Kharagpur Collaborative Research Laboratory and Electronics, Controls and Software. He held additional charge of Director IIT Partha and IIT Kalyan. Dr. Partha area interests include artificial intelligence, algorithms, formal methods, CAD for VLSI and embedded systems, and fault tolerance. He has made fundamental scientific contributions in the area of AI and automated reasoning, and has applied the techniques to solve important synthesis, optimization, and verification problems, especially in VLSI design and embedded systems. He has published 2 research monographs, more than 300 papers in international journals and conferences, and supervised more than 30 PhD students. Dr. PPC has worked closely with industry and government and has successfully completed projects totaling worth more than several hundred crores with the MHRD, DST, CSIR, uh, MNI, TLI, MEITI, DHI, INSA, Volkswagen Foundation, Intel, Synopsys, Google, National Semiconductors, General Motors, ONGC, to name a few. He was the founding architect and overall coordinator of national initiatives like National Digital Library of India, Global Initiative for Academic Networks, that is popularly known as GIAN, Spark, Imprint, PAD IIT, ONGC initiative, that are emerging as game changers in India's education research scenario. Dr. PPC received the President of India Gold Medal in 1985, the INSA Young Scientist Award in 1991, Anil K. Bose Award in 1995, INAE Young Engineers Award in 1997, and Swarna Jayanti Fellowship during 97 and 98, Santi Sirup Bhatnagar Prize in 2000, INAE Vishwesvaraya Chair Professorship during 2007 and 2009, J.C. Bose Fellowship in 2013, and many other awards. He has been elected as a Fellow of the Indian National Science Academy, New Delhi, and the Indian Academy of Science, Bangalore, Indian National Academy of Engineering, and the West Bengal Academy of Science and Technology. He received Doctor of Science from Kalyani University in 2018 and Honorary Doctorate in Literature from Techno India University in 2024 for the contributions to science and technology. We are really fortunate to have Dr. PPC as our chief guest to launch the book. Coming to the author and presenter, Dr. Tanmoy Chakrabarti is a Rajiv Khemani young faculty professor in AI in the Department of Electrical Engineering and School of Artificial Intelligence at IIT Delhi. He leads the Laboratory of Computational Social Systems, a research group that primarily focuses on building economical, adaptable, and interpretable language models and applying them specifically to two areas: mental health counseling and cyber informatics. He has served as the DAAD, that is the German visiting professor at MPI, Max Planck Institute. No, that is MPI Max Planck Institute, Saarbrücken, and PCFFAR, visiting professor at Technical University Munich, and the ELSIE visiting professor at Technical University Darmstadt. Dr. Tanmoy has received numerous recognitions, including the Alexander Van Humboldt Fellowship, Ramanujan Fellowship, ACL 23 Outstanding Paper Award, IJCI 2023 AI for Good Award, and several faculty awards from industries like Google, LinkedIn, JP Morgan, and Adobe. He has authored two textbooks, Social Network Analysis and the current one, The Introduction to Large Language Models. With this welcome note about the today's event and the introduction of the chief guest and the author come presenter, now I request the chief guest, Professor PPC, to formally release the book, felicitate the author, and address the gathering. Over to Professor PPC.
Thank you so much, Dr. Mohan. And I am grateful to IEEE, ACM, and CSI of the Chennai chapter for inviting me to be the chief guest of this program. And more importantly, identifying that a right book has come out at the right time when India needs it the most. As has already been mentioned, we are in exciting times. And we are in times when the humankind is faced with the challenge of a technology that appears to be more intelligent than it in all aspects. This has become a deadly tiger whom you can use to save humanity, or if you misuse it, you are going to be able to destroy humanity. That is the question that has come. So the most important thing for a nation like India is to be able to use it for its maximal benefit and bridge the digital divide instead of opening it up further. For that, manpower training is the highest requirement. The next generation of native AI people need to be born, taught, and come up with the technology to be able to make the impact that India needs to make nationally and worldwide. In view of these circumstances, I think we have got to a very good point where Dr. Tanmoy Chakrabarti has come up with this wonderful book on large language models. And this is an introductory book as well as an advanced book, and it introduces the topic most succinctly. So I would like to first welcome and felicitate Dr. Tanmoy Chakrabarti. As his biodata has already been mentioned, I would like to add on to say that among the AI researchers, the young AI researchers coming out of India, academics and researchers, he stands in the front row, sits in the front row of all of them. He publishes in the top frontier conferences and journals. He works on the latest topics and is therefore one of the most suitable persons to write such kinds of textbook material. So I would request all of you to put your hands together to welcome Dr. Tanmoy Chakrabarti and give him the warmest welcome and the warmest kudos.
Thank you very much, sir, for your kind words. Thank you
for coming up with this. In order to do this, I'm sure Dr. Tanmoy Chakrabarti will come up with more details about this book. I can just mention a few things about this book. That this LLM revolution started in the year 48 when the N-gram model came up. Then there was the distributional hypothesis. Then our recurrent neural networks. came up in 86. As we all know, AI has gone through this, crests and troughs, heights and sadness. And then after around 2000s, when word to vec, then the attention models, then transformers, and there is no looking back anymore. This book, which we shall release a little while later, captures the history in a very concise manner, introduces LLMs to readers gradually following the historical pathway, gives you the foundations of the NLP pipeline and architecture, including the basics of deep learning, word embedding. It's a self-contained book, statistical language model. Then it goes to the neural architectures. Then it takes you through the engineering. As I was mentioning a little while earlier in our casual discussions, that like an aeroplane, like a ship, large language models and the current trends of AI are not only scientific outcomes, but very, very powerful engineering marvels. So how to do pre-training, how to do fine-tuning, how to do model compression, parameter-efficient fine-tuning. And then the book goes into advanced frontiers of multilingual, multimodal, self-evolving models. And then the biggest topics of the day called hallucination. And then finally towards what is responsible AI. I'm sure that everybody will ask him about DeepSeek, so I'm not going to talk about it now. And this book also covers recent advances in LLMs. This book is not just a textbook as it is on paper. It is a full bouquet which has got a support system of electronic material in terms of video lectures, question banks, answers, and a dynamic team where the whole social connect of the book, because today's learning is of a different kind. So this is the much needed book at the right time when India wants to build foundation models. India needs talent to do this, and therefore I think that this is the right time. With this, with the permission of Dr. Mohan and Dr. Tanmoy and the rest of the team, it is my pleasure to release this model. This is it coming right, or is it coming in the inverse font?
This is coming right.
Right. So since it is coming right, I request you all.
Your page, you can just slightly lower it. Can you lower it? Yeah, that's slightly up, slight up. Yeah, okay. Now,
Or I can do this.
No. I mean, the earlier one is okay. Center and slightly up. Yeah. You are also visible and little bit up. Fine, sir. That looks fine. Just hold on. So I will take one picture. Okay. Yeah. Fantastic. 1 minute. One more picture I will take. Dr. Mayuk, you want to come on the camera? Dr. Mayuk, you want to switch on the camera? Yeah, okay. Otherwise, just hold on. Yeah, I am just taking a picture. One more picture. Little down. Okay, thank you, sir.
Thank you. Congratulations, Tanmoy, and congratulations and thank you.
Thank you very much.
It is my pleasure that when the young people do well, you know that things are in good hands. Our country, all over the country, we have now a number of young researchers coming up who are going to change and drive the scenario for India. Tanmoy is one of them, and I wish him well. Thank you, sir.
Thank you, Professor PPC. Now, over to Dr. Tanmoy.
All right. First of all, thanks very much. I'm speechless. I mean, I admire somebody like PPC. I mean, PPC sir is my father figure, right? I look up to him in every aspect, be it research, be it teaching, be it some advice related to my personal things, right? He is always there, and who else would be the best person to inaugurate the book than the PPC sir? himself. So I always call him the PPC sir because of the reason. So thanks again, IEEE CS Madras chapter, CSI Chennai chapter, and ACM Chennai chapter for this opportunity. Let me share the screen first. And thanks everyone for having me here today. I hope you can see my screen. Right. Okay. So I wrote this book. I started thinking about the book, I think 1.5 years back. I'd been traveling to different places to give talks, talks in faculty development programs, talks in different keynote talks, conferences, and different places. So what I felt is that people know what is happening, but people don't know how things are happening. The underlying techniques, underlying mathematics behind these tools and techniques are not very clear to the audience. So whenever I started speaking technical things, people actually started getting distracted. And then I realized that structured materials are very important, and that was the major motivation behind this. I'll talk more about the other motivations, but this is something that I felt very important. As Dr. Mohan also mentioned, I think 3 years back, 4 years back, 2021, during the pandemic time, I wrote another book on social network analysis. That was the book, that was the topic that I was interested in that time. And in pandemic time, I had enough time, so I thought, let us just jot down the thoughts that I've been teaching in all the material that I've been teaching. I wrote a book on social network analysis that time, and I had some experience, and then I thought this is the right time to write something on large language models, foundational models. Okay, so this is the title of the talk, large language models from pedagogy to research frontiers. So the way I basically speak about here, I'll first introduce the book, the content of the book, and then I will very briefly talk about the evolution of large language models, and I will try to connect every chapter of the book with the evolution, so that people understand why these chapters are important, right, and which chapters need to be carefully read. And then maybe last 10-15 minutes, 10 minutes, I'll talk about the research that we do at IIT Delhi, and and then we can take question and answers after that. Okay, so this is the book, and along with the book there are lecture slides, right? If you go to this link, this is the link of the book, tanmoycheck.com/LLM book. So for every chapter, with every chapter, you have a lecture slide. And some of you know that I recorded a 42 hours of course on large language model, which I offered last year at IIT Delhi. And this is a full-fledged course that I offered last semester here. And on LinkedIn and other platforms also, this got a lot of attention. More than 38 so far viewed these lectures, and more than 6k subscribers subscribed to the channel so far. So this would essentially act as a supplement to understand the chapter. And then you also have chapter-wise exercise and solutions. As this is a textbook, there are exercises and solutions can be obtained from me. If you are a teacher planning to teach this course, just send an email. I will give you the solution for every chapter, for every exercise. The solutions may not be given to the students, right, because of the obvious reason. And then in the book, there are also important links to the repositories like GitHub repos and other repos where important source codes, seminal papers are listed, right? You can actually play with those repositories for your projects, for your course projects, for your thesis, major thesis, minor thesis, and stuff like that. So the book is available on Amazon. You can go through this. The Kindle version of the book as well as the hard copy is available there. And some of you also know that I am offering an NPTEL course this semester. on LLM jointly with Professor Somen Chakraborty from IIT Bombay. So more than 14,000 students registered, which I was very, very surprised, very, very happy when I saw the number. A course like LLM, which is considered as an advanced, super advanced course, has been subscribed by more than 14,000 students so far. Again, if you are interested in taking a certificate out of this course, you can actually look at the lectures. But unfortunately, the registration ended day before yesterday. But you can still go through the lecture materials which are there in the NPTEL website. All right. So let me start with the motivation behind writing the book. As I mentioned, when I went for giving talks, I realized that not only students but also teachers, they're also struggling to find structured resources to teach, to learn, right? To learn from. And I thought, a book from which somebody can start the LLM journey, right, would be very, very important in today's scenario. No standard teaching material. Therefore, I thought, along with the book, if the slides are also prepared and lecture materials, lecture videos are also there, so somebody can just look at read the book. If things are not clear, go to the lecture material and slides also, and in that way people will relate these things properly. And then I wrote a book. I wrote this book in such a way that the industry folks can also connect with this, because in the chapter you see that there are coding exercises, there are some important code snippets, right, that somebody can try out, and that might be useful for industry folks also, those who don't have much ideas about deep learning and LLM, right? So they can also use this book to do some basic level coding. So this can also act as a bridge between academia and industry. And I think this is the first, to me, this is the according to me, I think, to the best of my knowledge, this is the first book on large language model. Also, this is the first book on LLMs where the advanced topics are covered. For example, advanced topics like very advanced topics like model editing, state space models, interpretability, right, and and other alignment techniques like PPO, DPO, and other types of techniques. These are mentioned in a simple. I tried to write in such a way that it would be understandable for those who don't have much background, and I hope things will be clear. And last and most importantly, if you see today's era on LinkedIn, on other social media, Twitter, there are many LLM gurus, right? They talk about LLMs. They also criticize papers. They promote papers, right? Like promoting products. They also promote products, promote papers. So let's say, if you archive some papers and if you want your papers to be promoted, you can go and talk to these gurus. Maybe you give them money, right, whatever, and they will promote this. So since there are so many gurus and people are confused sometimes that which guru to follow, I thought, let us not follow one of the gurus. Let us just let us just read the book, get some understandings, and then you decide which guru or who you essentially want to follow. And this is very important in today's time. Okay, so if you look at the book content, the book is essentially structured in such a way that it covers the basics, including basics intro to natural language processing, statistical language models, methods like word-to-vec, right, neural language models, and then it moves towards the architecture, where we discuss the transformer model, different types of decoding techniques, encoding techniques, pre-training strategies, right, advanced attention mechanisms, and mixture of experts. Then we move towards the learnability part of it, where we discuss instruction fine-tuning, alignment, in-context learning, and efficient language model inference. And then user acceptability, where we talk about very advanced concepts like RAG, retrieval augmented generation, and multilingual models, multimodal models, vision language models, how to handle long context, model editing, tool augmented language models, reasoning, and stuff like that. And we we then we conclude the book with topics like responsible AI, bias, toxicity, hallucination, and in action, where we include topics like all the GPT series models, Llama series models, and different code snippets to essentially give more flavor of the implementation part of it. So in that sense, the book is essentially a balance of balance between the theory and the implementation part of it. Okay, so the book starts with the introduction, as I mentioned, where we talk about the evolution of language model, right? And to understand the remaining chapters, I thought the basic NLP knowledge and basic neural network knowledge is very important. So I wrote the very basic. Sorry, what happened? I wrote the very basic basic NLP part which are needed. Of course, this is not a complete NLP book, so I only focused on those concepts which are needed to understand the remaining chapters. And of course, in the neural network, I mostly focused on different types of loss functions, how to do back propagation, right? Back propagation through time, and other complicated aspects which are related to neural network, which are needed to understand the remaining chapters. So let us start understanding what a language model is, right? So we use language models in our day-to-day lives. For example, when we search something on Google search, right? Let's say we write, how did Virat Kohli? We see that there are auto suggestions, right? Like, how did Virat Kohli start his career? How did Virat Kohli learn English? How did Virat Kohli meet Anushka Sharma, and so on and so forth? So these are called auto completion, query auto completion. Now, how this auto completion actually happens? Now, there is an underlying language model which basically is used to do this auto completion. And if you look at it very carefully, this is essentially next word prediction, right? So given a context, right, your task is to predict what's going to be the next word or next sequence of words. And this is exactly what a language model is. So the bookish definition of a language model is a probability distribution over a sequence of tokens. A sequence of tokens can be sequence of words, sequence of images, sequence of numbers, sequence of anything, right? So in the context of large language models, this is basically sequence of words. And the words, when I say word can be a valid dictionary word. A word can be a token like a subword. Word can also be a character. So therefore, we don't use the term word, we use the term token, right? Token can be a word, a subword, a character, even a pair of words, for example, right? So this is essentially a joint distribution over a sequence of tokens. Now, if you use chain rule, you can essentially unfold a joint distribution into conditional probabilities, right? So if you look at each of the conditional probabilities, it is basically next word prediction. Given the context where the tokens are W1, W2, W3, Wn minus 1, what is going to be the probability of the token Wn? So this is statistical language model, right? Now, how do you measure this probability? You have the corpus, you count n-grams, right? And you essentially compute this probability. So let's say your context is, I like pizza with lots of dash. If your language model is good, it will suggest the word cheese with a probability 0.85. If your language model is not that good, it will suggest corn, right? And if your language model is really pathetic, it will suggest tree, right? So this is all about next word prediction. So in chapter 4, which is on statistical language model, I talked about the statistical language model objective and different types of smoothing techniques, right? Because most of the cases we see that when you use a corpus for n-gram count measurement, we see most of these n-grams don't appear in the corpus. Therefore, you see, if you look at all these probabilities in the joint distribution, if one probability gets 0, the entire probability will be 0. So can we think of smoothing mechanism to make this probability non-zero, right? And then we talk about evaluation. So how do we evaluate a language model? Methods like perplexity, right? Some of you know Shannon's character guessing game, and Shannon, used to play this character guessing game with his wife, and what is the character guessing game? So given a sequence of characters, what's going to the next character? So it turned out that Shannon's wife was actually very successful in guessing the next character. In fact, within 3 to 4 guesses, she was able to 3 to 4 attempts, she was able to successfully guess the next character, right? Worst cases, she used to take more than 9, but average case around 3 to 4 attempts. So from that experiment, Shannon came up with this idea of perplexity, and he showed that the perplexity has a very nice correlation with entropy, Shannon's entropy. So if you look at English, for a native English speaker, the perplexity is 3 to 4 again. I talk about this, and then the limitations of statistical language model, motivation behind the neural language model. So the neural language model essentially started by this seminal work by Yoshua Bengio. Yoshua Bengio, some of you know, he's one of the godfathers of deep learning, who got ACM Turing Award. Yoshua Bengio wrote this paper, A Neural Probabilistic Language Model. This is the first paper which showed how language model can be modeled using a simple feed-forward network. Okay, and that was the beginning. So in all these aspects, be it statistical language model or neural language model, the basic input is the word, right? So how do you feed a word into the language model? So you can't feed the English word, or let's say the Chinese word, or the, let's say, a Hindi word, right? So you have to have some sort of representation for the word. So there had been a lot of work in between 2010 to 2013-14, how to appropriately represent a word. Method like word to vec was proposed, and then Chris Manning from Stanford, he said that word to vec is not a very good approach, because it doesn't consider the statistical part of it. Word to vec is mostly a neural approach, totally a neural approach. So he as his team came up with this idea of GLOVE, embedding global vector representation, which is a mix of neural network as well as statistical approach. And then Facebook said that we have a lot of social media text. Let's not look at words. Let's look at subwords and characters. And they came up with this the new embedding technique called fast text. Right. So these 3 techniques are very well known for word representation. So, this chapter 3 talks about word representation, distributional semantics, hypothesis, the hypothesis of distributional similarity, distributional semantics, and then different word embedding techniques, biases in word embedding techniques, and limitations of different, all these techniques. So, now we were around 2013-14, that time where neural language models were very popular, specifically for machine translation. Models like CNN, were proposed for language modeling, and then people saw that CNN is not a good way, because language is essentially a sequential structure, right? CNN doesn't capture sequence properly. Then they used RNN, and advanced version of RNN like LSTM and GRU, where gated mechanisms are there. But all these methods essentially are sequential, so you cannot process tokens in parallel, right? You have to wait till t-1 to process the word at tth time. So what you need? We need something which can process tokens in parallel. By the way, so in chapter 5, all these neural language models are discussed, including CNN-based methods, RNN-based methods, sequence to sequence, and the attention mechanism which was proposed around 2013-14. Then, if you look at the timeline of NLP or whatever LLM, earlier days IBM used to dominate the entire AI research, right? We all know IBM Watson model, right? Which basically the Watson model won the Jeopardy challenge in 2011, which was a live quiz show 2011. And then Google Brain Google Brain started around 2014. Google started building their own processing unit called TPUs. And then there is a company called OpenAI, which was founded during 2015. 2016, that time, Stanford came up with a very famous data set called the Squad dataset, right, which is used for the evaluation purposes. And then in 2017, Ashish Vaswani and his colleagues from Google Brain, they wrote the transformer paper, which is which is considered as a breakthrough in AI. After that, all big giants, including OpenAI, Google, and Meta, they started building their language models, where OpenAI started focusing on their GPT series, right? GPT 1, 2, 3, ChatGPT, GPT Neo, GPT-J, GPT-4, and recent O1 models. Google started building their bot models, Robota, Debota, right, and stuff like that. They recently they started building their Gemini series models and small models like Gemma. And then Facebook saw that OpenAI has already dominated the LLM world. So what to do now? So they started making these models free of cost. They started building their Llama series models. Although Llama, experimentally, we have seen that Llama is not that great compared to GPT, but nevertheless, Llama is open source model. So if you don't have money, if you want to build your independent LLM stack, or let's say if you want to build something which is confidential, let's say healthcare or medical domain or other domains, you can use Llama for your stack. And of course, recent DeepSeek model, this has been released as an open source model, but we really need to look into it very carefully, because although people say that things are open source, when it comes to implementation, it's very difficult to check whether this is really and complete open source or not. Nevertheless, coming back to the transformer paper, this is the famous paper, I think, which got more than 1 billion clicks so far on the web. This has encoder and decoder stacks. So chapter 6 talks about transformer, self-attention, transformer encoder block, decoder block, different types of positional embedding techniques, right? And so on and so forth. Advanced attention mechanisms. Again, this is, I think, I have not seen any single source where all advanced attention techniques are also proposed. For example, recently, DeepSeek proposed this multi-head latent attention, which is considered as another advanced attention mechanism, right? So this is the chapter for this. So if you look at the attention framework, there is this encoder block and decoder block. Methods like encoder only methods like, encoder only methods like bot, debota, robota, they use something called mask language modeling, where you mask some of the words and you ask the models to predict those words. And this is completely self-supervised. You don't need any label data to train this model, right? Whereas GPT models, GPT Llama, they are decoder-only models, which basically work in a setting called the mask self-attention mechanism and next word prediction, autoregressive model, next word prediction, right? This is also called causal language model. So in chapter 7, we talk about different types of language model pre-training, pre-training encoder model, pre-training decoder model, and the other emerging topics of pre-training strategies. Okay, so we saw in 2018, 2019 that we don't need a uh, something to train from scratch. What you need, you have a pre-trained model, right, which knows the entire world's knowledge, right? I mean, I should not say the world's knowledge. The pre-trained model knows the nitty-gritties of a language, syntax and semantics, and then you fine-tune the model for your downstream task, right? Let's say you have you have a summarization task, you fine-tune your model for summarization task, and you use this for prediction. So this is a standard pre-training, fine-tuning, and predict pipeline. In 2020, this GPT-3 paper came, and they saw a very interesting phenomena, right? They saw that we don't need to fine-tune the model anymore. You just write some prompt, and your model starts essentially, acting on your prompt, right? So this is the first paper where the term large language model was proposed. Remember this. And this is the first paper where the term foundational model was proposed. OpenAI's GPT-3 paper. So therefore, a new paradigm emerged, which is called pre-training, prompt, and predict. You don't need to fine-tune the model. You just need to write your prompt efficiently, and the model should be able to follow your prompt, right? We all know that LLMs are surprisingly smart, right? You write prompt, you write things in context, zero shot, few shot setup, the model will be able to follow your instructions. If you think that the model is not following it properly, you write chain of thoughts prompting with steps, right? Model will be able to follow your reasoning behavior, and the model will try to mimic the reasoning behavior, right? And then there are advanced prompting techniques like chain of thoughts, self-consistency, tree of thoughts, graph of thoughts, and many, many more, right? Chapter 9 talks about prompting strategies, different types of promptings, prompt engineering, chain of thoughts, tree of thoughts, graph of thoughts, and many more advanced prompting techniques. Pre-trained models are great. You write prompts, the model will be able to respond. But if you ask your model to follow instructions, right, in a conversational setup, the model will not be able to do that. For example, if you write a prompt that write a poem that describes a sun getting dipped in chocolate, right? You say that you see the model basically, produces a sentence like, it should be a hyaku, it should be about a sun getting dipped in chocolate, and these two sentences get repeated again and again. This is not exactly what you wanted, right? So it is not able to follow your instruction properly. So people started thinking how to make this model so that it will follow the instruction properly. So they came up with something called instruction fine-tuning, right? In instruction fine-tuning, you have many data sets, many tasks, right? And there is this famous data set called FLAN T5. This was proposed, and there are more than thousands of tasks which were used to instruction fine-tune the model. So now the model knows how to follow your instructions, right? Unfortunately, this is not enough. Why? For example, if you ask your model, your LLM, instruction fine-tuned LLM, what is the best way to lose weight quickly? Your model may say that you should stop eating entirely for a few days, right? This is a wrong advice. The model should say that you reduce your carb intake, increase fiber, increase protein, do rigorous exercise, and so on and so forth. So how you force your model not to produce something wrong, something misinformation, something wrong advice, something wrong health information, but to produce something sensitive, right? So, and this is called alignment, right? So in 2022, again, OpenAI came up with this idea called Instruct GPT, right? So Instruct GPT, now they use the old school, very, very old school reinforcement learning method. They tweaked it for language model fine tuning, right? And they came up with a technique called RLHF, reinforcement learning from human feedback, or reinforcement learning with human feedback, right? So this is typical RL framework. You have a policy model, which is the LLM. You have a reward model. Your policy model generates multiple responses. Your reward model is already trained to produce reward for all these responses, and you keep on essentially updating your policy model based on the feedback that you obtain from your reward model, right? So this is not all, by the way. Remember, in traditional RLHF setup, you can hack your reward model. You can write responses or generate responses so that your reward model starts producing high reward, but those responses may not be human-like, right? So in RLHF, they came up with a very interesting objective function where they minimize the KL divergence loss between the policy and the policy model and the reference model, and then you have a reward model which you want to maximize. Okay. So what is ChatGPT or today's GPT? Today's GPT is nothing but an instruction fine-tuned GPT with an RLHF alignment. Right? This is multilingual, multimodal, task agnostic. Unfortunately, it was also came to the notice that OpenAI hired many cheap Kenyan workers to clean their data sets, right? To essentially make this data set for RLHF, right? You understand that to do RLHF, you really need huge amount of data sets, right? And you may wonder, how did they get such a huge amount of instructions, right? For doing RLHF. The instructions came from us, right? We people started using ChatGPT models, right? And we people started giving prompts to them, many diverse prompts, and they started curating those prompts, and then removed some of these prompts, which some of the responses which are toxic, biased, not useful, and stuff like that. All right, chapter 8 talks about fine tuning and alignment, right? Very detailed chapter with multiple alignment techniques, not only RLHF but methods like DPO, which is an advanced version of RLHF. And some of you know, recently DeepSeek, they use this GRPO technique, right, which is another policy optimization technique, advanced version of DPO. Augmented LLM. So 2022, 2023, people realized that LLMs are not, they are not God, right? It's like, it is not possible for a single LLM to do all sorts of tasks, right? So what to do? You teach your LLM to essentially call different other tools. For example, we have old school calculators, we have symbolic solvers like Python interpreters, we have search engines, we have specialized question answering tools, right? So you teach your LLM to essentially call all these external tools, be it calculator, right? Wiki search engine, question answering tool, and stuff like that. So a technique called tool calling, tool former, was proposed at that time in 2022. And then people also realized that the internal memory of LLM is not enough. We need augmented data. So people started, people came up with this idea called retrieval augmented generation, RAG, where you take knowledge from external sources. Knowledge can be a data set, knowledge can be a table, knowledge can be a knowledge base, a knowledge graph, it can be anything. And then you start teaching your LLM how to appropriately use all these external thesaurus, all this external knowledge, right? Chapter 11 talks about augmented language models, RAG, tool calling and other, and of course LLM agents, right? Some of you know that agent is again one of the hot topics these days. Some of the challenges in LLM language models are really large, right? And people like us, academicians, poor academicians, who don't have access to thousands of GPUs, we don't have access to huge funding, we won't be able to fine tune this model. So can we think of efficient fine tuning, right? Parameter efficient fine tuning. So methods like prompt tuning, prefix tuning, adapters, right? Low rank adaptation, LoRa, some of you know techniques like LoRa, DORA, ACE-LoRa, and so on and so forth. Those methods were proposed, and people also started thinking about model compression, right? Some of the model parameters are not useful. How can we compress them during the inference time? Model like distillation was proposed. If you see DeepSeek methods, DeepSeek models, and Llama models, also OpenAI, Gemma, all the small models are essentially distilled version of the large teacher model, right? So chapter 10 talks about efficient fine-tuning, model compression, PEFT, and other advanced efficient fine-tuning strategies. Potential threats. Some of you know that LLMs hallucinate. So hallucination can be extrinsic hallucination, intrinsic hallucination. If you use LLM for let's say job recruitment, for any other decision making process, they are heavily biased. So we need to think of responsible AI. LLMs can also produce misinformation. For example, LLM, one of the LLMs said that Bill Gates is responsible for COVID-19 virus and all this vaccine-related debate. If you use LLM for mental health, you may not be surprised if your LLM will suggest you to join some sort of cocaine gang, right? Some sort of smuggling gang, some sort of cocaine cartel and stuff like that. If you use LLM for your literature survey, right? Let's say you plan to explore a new topic, you use LLM for literature survey, you may not be surprised if you see some of the papers suggested by LLMs do not exist, right? For example, recently I tried, so I wanted to work on adaptive summarization. I tried prompting this, and I saw some of the papers which looked very interesting, but in reality, none of these papers essentially exist. So chapter 13 talks about responsible LLMs, bias, mitigation techniques, and so on. So to me, these are the non-exhaustive list of hot topics these days. LLM agents, of course, interpretability of LLMs. People don't know how these models essentially work. We need better mixture of experts kind of techniques, better alignment, handling long context, and then knowledge editing, and then better inference mechanisms like state space models and other inference methods which essentially can help you reduce the inference time. Okay, so chapter 12 talks about multilingual models, multimodal models, vision language models. Chapter 14 talks about chapter 14 discusses very advanced topics like reasoning, handling long context, model editing, hallucination, and chapter 15 is on LLMs in action, where we described all state-of-the-art language models like GPTs, llamas, and how you can do practical implementation with these models. This is more of a practical part of the book. Okay, with this, I stop the second part, and I will take 2 to 3 more minutes to introduce my lab. Okay, so this is the lab which I lead at, not lead. I am fortunate to be a part of this lab. There are PhD students, postdocs, masters. You can also see my son, 2 years old son, who is also part of my lab. And the lab is funded by major industry partners: Google, Facebook, LinkedIn, Accenture, JP Morgan, Adobe, even IBM, and many other industries, and also, of course, government agencies like MeitY, DST, MHRD, and so on. This is the focus of the lab. We build economic models which are parameter efficient, right? We build adaptable models which one can easily adapt across tasks, right, without changing the architecture much. And we try our model to be interpretable, right? So that decision making process can be easier. So the quest of designing small language models started way back 2021, where we essentially redesigned the transformer model using particle physics, right? We showed that the way a word moves from one layer to another layer in transformer, this is same as a particle moving from one spatiotemporal region to another spatiotemporal region. This is nothing but a spatiotemporal region shift. And we then borrowed ideas of all this ordinary differential equation from particle physics, and we redesigned the entire transformer model. And we showed that the redesigned model has 1/3 of the model parameters that are there in the actual transformer model. And this was the spotlight paper in NeurIPS 2021. In economical model, we focus on knowledge distillation, right? Unimodal knowledge distillation, where teacher models are a big model. For example, let's say a Llama 175 billion model, or let's say a stable diffusion model, right? And a student model is a 1 billion model or 0.5 billion model. So how you can efficiently distill knowledge from a teacher to a student, right? How you can think of adaptive knowledge distillation, structured knowledge distillation, right? And so on and so forth. We also did work on model on inference time optimization, where we and this is more of a theoretical work, where we basically talked about how we can think of activation compression, activation sparsity, and we related. We basically tried to make an analogy again with the entropy and information gain across different layers in transformer, right? We showed that if you do activation compression, activation sparsity, this would essentially help you better, help you make the inference time much faster. We also work on model coordination, where we have multiple models coordinate with each other. We also teach the models to better call tools, right? In one of our ACL papers in 2023, we showed that how you can use small language models to essentially decompose complicated reasoning problems into sub-problems, right? And then this will help the large language model to problems. Complicated problems include, let's say, IIT JEE questions, math Olympiad questions, and so on and so forth, right? So we showed how SLM, small language models, can help large language models in solving those problems. In adaptability, we look at better parameter efficient fine-tuning. We came up with a method called ID3, which is a better version of LoRa. In a follow-up work, we we redesigned LoRa with Bayesian optimization, right? We took inspiration from Monte Carlo optimization and we redesigned entire LoRa adapter. And it turned out that our Monte LoRa, which is a Monte Carlo optimized version of LoRa, is quite robust to external perturbation and other other things. And we also look at in context adaptation. Let's say you have high resource languages like English, Chinese, and low resource languages like say Bengali, Tamil, Telugu, Gujarati. How you can use high resource language examples to write prompts for low resource language. So we came up with an idea called cross-lingual in context learning, which got Outstanding Paper Award in 2023 ACL. Interpretability, I think our work is the pioneering work in understanding how chain of thought works. Some of you know chain of thoughts is one of the advanced prompting techniques, but nobody knows how LLMs actually digest a chain of thought kind of prompt, right? So using mechanistic interpretation, we showed that when you write a chain of thoughts prompt, there are multiple redundant neural pathways which are responsible for solving the chain of thought prompts, right? Addressing the prompt. So if you remove 40 to 50% of those neural pathways, meaning you basically mask those neural pathways, right? You still will be able to get two groups. The bottom layers are responsible for Ball's knowledge, right? Pretend knowledge, whereas the top layers are responsible for in-context knowledge, right? So these are the major findings behind, these are the major findings of the COT reasoning. Now the question is, once we understand how COTs work, can we use some of this interpretability for better model building, right? So we then recently, submitted a paper where we showed how we can think of mechanistic model editing, right, for better language performance, better language modeling. So these are some of the major ongoing works on foundational models. As I mentioned, we apply LLMs in two areas. One is mental health. So in collaboration with AIIMS Delhi and NIMHANS Bangalore, we are currently working on designing a social robot which will interact with a mental health patient before the mental health patient goes to the doctor. If you go to AIIMS Delhi, you see that there's a robot standing in front of the doctor's chamber, right? Doctors, each of the doctors, as you know, that the number of therapists, mental therapists, is much lesser than the number of mental patients these days, right? And every therapeutic session takes more than an hour. Can you think of some sort of avatar therapy? So this is called avatar therapy. Avatar therapy. This is a very famous term in the West. So in avatar therapy, a robot interacts with the mental health patient, right? Tries to understand what the patient suffers from, then summarizes the entire discussion, makes a pre-diagnosis report, and that report is given to the doctor for further assessment. So this pre-diagnosis report will act as a prior for the doctor for better assessment. And we showed that if you do this, if you use this kind of robotic, robotic kind of conversation before the actual therapy, this would essentially help you in two aspects. One, the total therapeutic time can be reduced from 1 hour to 30 to 45 minutes, right? And if you save 15 to 20 minutes per patient, a doctor would be able to attend to more patients every day, right? Secondly, we also saw that patients are more flexible or more open to interacting with robots compared to a doctor, right? Because sometimes doctors, different doctors have different moods, different ways of speaking, mental health being such a sensitive issues, patients are reluctant to express themselves, right? So patients are more open to interact with the robot compared to interacting with the doctor. So this essentially helps a lot. So we are currently designing the full-fledged version of this. We wrote papers in some of the medical journals like JMIR Mental Health, and of course PLOS One Mental Health, and recently Nature Machine Intelligence with AIMS doctors and EMHANS. The second application that we focus on, and this is something that have been working since last 6, 7, 8 years on social media. We look at misinformation, fake news, different types of online harm, right? And we design techniques to detect them, combat them, and then come up with proactive strategies to stop the spread of online harm, right? So along with all these top conference papers, we also wrote papers published in Nature Machine Intelligence, right? A couple of papers in Nature Machine Intelligence, and and so on and so forth. And this we have built different models, a series of models, designed prototypes, gave the prototypes to major industries including LinkedIn, Accenture, Wipro, and they deployed those prototypes into their stack for practical usage. This is it. Thanks for the opportunity, and once again, I am really thankful to PPC sir for not only his presence but also inaugurating the book here in this forum, and my heartfelt thanks to IEEE, ACM, and CSI chapters of Chennai. Thank you very much, and I'm open to if you have questions, please let me know. Thank you.
Yes, sir. Akila ma'am.
Yeah. Thank you, sir. Thank you for your excellent session. There are a few questions being posted in the chat box and also during the registration. Let me first ask you the question that is in the chat box. Mr. Mayuk has asked you a question. Kindly share your thoughts on LLM hallucination in interdisciplinary and creative study. Can there be a positive use case for this phenomena?
That's an excellent question. And look at this paper that we wrote, this paper, okay, this Nature paper, where we argued that hallucination sometimes is really useful, right? Specifically when it comes to creativity. And but one needs to be very careful about judging whether it is hallucinating or not. For example, some of you know when the movie Rang De Basanti came, I think 2003, 2004, 2001. A.R. Rahman, the genius A.R. Rahman, so he gave the music, and that time people started criticizing the music because the music was not very contemporary, right? And people started thinking that no, this is not something which people should appreciate. In after 3 to 4 years, people realized that the music was way beyond the time frame, right? And I always feel that when it comes to hallucination, be it story writing, poem writing, right, news article editing, or let's say models like DALL-E, stable diffusion, drawing images and stuff like that, making creative. Whenever creativity comes to the picture, right, I think we should allow the model to hallucinate, right? So therefore, I always say that LLM should be a tool for an expert, not for a layman, right? If a layman uses a LLM for let's say for assignment, right, or for preparing questions, or so on and so forth, or solving complicated maths reasoning questions, he or she needs to be very careful because the model can hallucinate. If you are really expert in certain topics, you let the model hallucinate, and you are the judge. You'll be able to answer. You'll be able to understand the response of this LLM and judge whether it is creative or not. So the answer, so long and short answer to this question is hallucination is good when it comes to creativity. And there are papers which actually claim that you cannot stop the model to hallucinate. This is an inherent property of a model, because remember, ultimately all these LLMs are next word predictors, right? So you cannot stop them to hallucinate.
Thank you, Professor, for the explanation.
Thank you for your precise answer. Thank you, sir. The next question. Meta has released large concept model. How you see it is going to impact the evolution and adoption of LLM in the academic community?
So large context model, again, LCM is a new technique that Meta hypothesized, right? Similarly, Ian LeCun has been hypothesizing something called the world's language model, right? And these are considered as advanced version of next word prediction. Okay, so for example, in words in words model, you look at the frames, and you look at how LLM can predict the frames way ahead, not the next frame, but multiple frames way ahead, and you see how the model can predict. Similarly, this concept model, right, if you look at the way this large concept model was proposed, you essentially you don't look at the next word, you look at the embedding space, and within the embedding space you essentially predict the next word or next few words. I would say that these are not a very established concept till date. Okay, large concept model, world's knowledge, large world's model, I think it needs a bit more exploration to essentially establish that these are essentially useful for building generative AI. I think large language models use mostly autoregressive methods like next word prediction, which has been established across different models. I think we need to maybe wait for a couple of more months or maybe a year to see whether this LCM is really a good approach or not. Thank you.
Yeah, Dr. Claire.
Yes, ma'am. Yes, ma'am. 1 minute, ma'am. Sir, the next question. Role of LLM in hate speech detection and mitigation.
This is what I've been doing.
Yeah.
LLMs are used. So remember, there's a concept called jailbreaking. Okay, although LLMs are fine-tuned in such a way that they should not produce any hate comment, produce any fake news, but still there are methods like different jailbreakings through which you can jailbreak and insist your models to produce something hateful, right? So, and then at the same time, I mean, of course, remember, in any setup there are attackers, there are defenders. Attackers will always attack all these models to jailbreak and to break the guardrail and to produce hallucinated fake hate speech, fake content, hate speech. At the same time, responsible researchers like us, we should think of how we can think of better ways to essentially guardrail these LLMs, right? So there are different guardrail strategies. Alignment is the best way to guardrail this. For example, if you look at DeepSeek has been designed in so appropriately that if you ask any sensitive question, right? For example, questions related to Tibet, right? Question related to any controversial questions, you see that it will not answer. So this attacker defender trade-off will always be there. The fight between attacker and defender will always be there. Being a responsible person, we should think of better LLMs which would essentially guardrail all this jailbreak typical commands, typical prompts which can jailbreak the model.
Thank you, sir. So you have talked about large language models from pedagogy. So there is a question related like that. How you see this with India Bharata perspective?
What should I say? A couple of days back, some of you know that ministry has announced that India is going to launch its own Desi version of large language foundation model in 10 months, within 10 to 12 months, right? And they have also released a call for proposal for that. It's a right opportunity for startups and industry folks, academicians, to jump into this and leverage this opportunity, build India-centric model which can encompass 22 different languages, address a whole lot of biases that are there in India, right? Indian bias is very different from the Western bias, right? So all these ChatGPT models are biased towards Western culture. DeepSeek is biased towards uh, Chinese culture. We should think of models which can essentially address Indian societal bias, and I hope that within a year or so we'll see Indian LLM which will be multilingual, multimodal, and responsible.
Thank you, sir. Next question. Where can we, like it is I think it's from a researcher student point of view, where can we actually get data sets to create our own LLM?
So if you think of pre-training, right? Pre-training is extremely difficult. Although there are some pre-trained data sets available publicly, but pre-training is not something that we can do. If fine-tuning, there are specialized data sets. For example, task-specific fine-tuning, there are data sets in Kaggle. There are data sets data sets released by different industries, open source data sets that you can try out. Also GitHub also stores many data sets which you can use for fine-tuning. There is not a single repository, by the way. There are multiple repositories.
Thank you, sir. How LLM will help to solve the challenge of wireless communication when data availability is less?
I'm sorry, I don't have any idea. Wireless communication is out of my knowledge.
Oh, okay. So will India be creating products similar to DeepSeek soon?
Yeah, that's what I said, right? That's what I said. After this ministry's announcement, hopefully within a year or so, we'll see a new Indian version of LLM.
One last question, sir. It is like you have already answered it. Why it is taking time for Indian companies to build an Indian large language model?
I mean, I don't want to comment anything in publicly. Okay. I mean, I have a very different opinion, which is slightly controversial, right? But I just hope that within a year or so, India will produce something new. That's what I can say at this moment.
Sir, thank you for your excellent answering for all the questions they've raised. Sir, yes, sir. HR Mohan, sir, yes, sir. Sir, you're in mute.
Yeah. Professor Tanmoy, I just want to ask one question. Yesterday, there was an announcement that Ola founder is investing 2,000 crores in Kritam and also plans to invest up to 10,000 crores in the next year. You have any comments on this? The investment seems to be much higher when you compare to the order of Government of India's plan of investment.
I really welcome all these opportunities. I feel, I mean, if at the beginning of the session, PPC sir was also talking about money versus right talent, right? There are people who actually speak a lot, don't do anything. There are people who speak less, but actually do the real job. I hope and I expect that these opportunities will be given to those who are actually doers, not the speakers, right? These are really, really good opportunities, and I think we should leverage this. We should take this thing forward, but only to compete with DeepSeek, or only for the motivation to compete with ChatGPT. We should not start something, building from scratch. I think the aim should be broader. The aim should adhere to India's civilian, India's society. The aim or theme should focus on India's need, rather than competing with DeepSeek or competing with OpenAI. Right? That should not be the goal. The goal should be different. That's what I can say. But all these opportunities are really, really welcome.
And what about the point that our data is still we are not having data related to building our own model?
We have data set, Dr. Mohan. We have data sets. We have, for example, for doing pre-training, right? You essentially need what? You need massive corpus. For example, you can use Wikipedia. You can use news articles. There are plenty of news articles available online, right? You have many.
It is with respect to Indian context. When you want to build the LLMs for the Indian context.
No, so you also have Wikipedia written in Indian languages. We also have Indian news articles, right? Think of the Times of India statements, right? Hindustan Times, and then Dainik Jagran and all these local newspapers, right? And the entire dump is available there on the web. Data is not a problem. The problem is systematic curation of data and cleaning the data. And then, remember, building a foundation model doesn't require a lot of scientific innovation. It requires a lot of engineering innovation, right? Data cleaning, data processing. Then you also need to go into GPU level computing, right? CUDA level computing, understanding which type of compute will help you do faster GPU threading, multi-threading, and a lot of things are needed. So engineering effort is more important rather than scientific innovation. Because if you look at DeepSeek, right? DeepSeek, there are only two major innovations that you see. One is this new attention mechanism, multi-layered, multi-latent attention, and the other is this GRPO, reinforcement learning, right? The remaining thing is known. This is transformer. Llama, for example, right? So the underlying thing is known to us. We know that this is the underlying backbone, and we need to essentially train the model on this backbone, right? So it requires a lot of engineering effort, and therefore I feel that all these initiatives taken by Government of India and whatever, Kruti AI, NVIDIA, and all these recent announcements, startups should jump into this opportunities, and they should tie up with industries, academics. They should tie up with academics who work on LLM, right? Academics can act as an advisor, as an AI advisor, whatever, right? But the industry should essentially take the major role in implementing this.
Okay, thank you. Yeah.
Thank you, sir.
Okay.
Yes, sir. Thank you, sir. Now, I request our chair, Dr. K. Komathy ma'am, to formally end the session with the vote of thanks.
Yeah, thank you, Dr. Akila. Good evening, all. I thank the organizing units IEEE CS Madras, CSI Chennai, and ACM Chennai for arranging this book launch presentation with the topic Large Language Models from Pedagogy to Research Frontiers. We sincerely thank Dr. Partha Pratim Chakrabarti, Professor, Department of CSE and former Director, Indian Institute of Technology, Kharagpur, for his presence to release the book, felicitate the author, and address the participants. And Dr. Tanmoy Chakraborty, Associate Professor, Department of Electrical Engineering and School of AI, Indian Institute of Technology, Delhi, Rajiv Khemani, Young Faculty Chair Professor in AI, and the author of the book Introduction to Large Language Models, for his informative presentation on LLM. In his presentation, Dr. Tanmoy introduced the book and detailed its contents such as basics of NLP, NN, neural network techniques are described in the book. The book also covered statistical language model, first natural language model, neural LMs using CNN, RNN are discussed. Large language models brought out by OpenAI, Meta, Google corporates were discussed. Transformers, a stack for encoder and decoder blocks, that is also discussed. Changeover to prompting techniques were added to LLM. Instruction, fine-tuning, and RLHF methodologies were introduced. ChatGPT and DeepSeek tool-augmented LLM models are discussed. Challenges in LLMs, followed by the research directions in LLM, are vastly covered. Advanced topics in LLM are further included in the book. Applications of LLM, such as mental health and social media, which are also discussed in the book. With this brief note, I thank once again Dr. Tanmoy Chakrabarti for clarifying the queries raised by the participants both offline and online. I thank our mentor, Mr. H.R. Mohan, Chair Events, IEEE Madras, who work meticulously to bring eminent speakers for familiarizing the recent trends in computing technologies for the benefit of our members. I sincerely appreciate the participants who joined us in live Google Meet and YouTube live streaming. I thank the event team members from the organizing units for their support in arranging this event. With these warm words, we move to the end of today's event. Thank you all and good night.
Thank you. Thank you very much. Bye. Good night.
Good night, sir.
Thank you. Thank you, Professor Tanmoy.
Thank you. Please share the photos and videos with us, okay?
Yeah, we'll do that.
Definitely.
Thank you.